Hello, my name is Paweł Peregud, also known as Pepesza,
and I am Mike Chiliński.
Together we will present you our the way how we staked 100,000 ETH of Golem Foundation funds using QuebesOS.
At least it will be our journey and path which we decided to take on that journey to make it happen. And in fact, we are exactly at the moment when all of those ethers are starting to be active on the network. So we are really excited right now to be able to speak about it exactly on that moment.
If the phone will ring and Mick will disappear in a puff of smoke, the servers are down, right?
Yes, the truth is that when I feel an email is coming to my email, that are probably notifications from our network operating center, so it makes me really stressed. So please forgive me.
Yeah, so first, some introduction. You've probably heard about the merge. It happened on the 15th of September last year. And the two networks which previously was like independent from each other, ETH1 and ETH2, got renamed into execution layer and consensus layer. Execution layer, so Geff and friends, they've dropped the fork choice rule and started using consensus layer for tips through the socket. So now all of us who are running a full node have to run two clients together. And from the 15th of September, the new network is called just Ethereum 2.0 after the merge, proof of stake network. Yeah, so some facts or maybe judgments about proof of work and proof of stake, as you can see. Like, this stuff is likely the most technical thing you will see in this presentation.
That's not true in my part. There will be a little bit of technical parts.
So, but like from our point of view, ETH users, the most important thing is now we finally can be block producers from home, right? We no longer need to have those pesky, energy-intense mining rigs anymore, and I'm running staking from home. It's like two small boards, each consumes around 15 watts of energy, and one is a backup for another, and the uptime is really nice. So it's a pleasure nowadays. Yeah, so as I've mentioned, this home staking is easy, right? Like, I can do it, a lot of other people do it, but there are some problematic things there. First, now, so instead of basically running a really hot validator machine, you have now a key pair which can sign a transaction which will damage security of your funds. So those keys are hot. That's one problem. You usually don't store your keys hot if any amount of money is attached to it. And the other thing, if you will sign at the same slot or same height, the similar messages, you will get slashed. So this is like the main problem. Yeah. But like Ethereum designers, they've made they give us some hints of how we should run those networks. Like you can see those hints in the rewards and penalties structure. There is a small reward for attestation. It's like 3 steps ahead, like 2 cents at the moment. There is a really small penalty for missing an attestation. You attest every epoch, not every epoch,
every
right?
6 minutes, yes.
Yeah, 6.5 minutes, yeah. And by the way, to attest it, you need to be online, I believe, for the whole duration of epoch, because you are a part of committee and you need to sign every block, as far as I understand. But like this is a detail, right? But if you miss this attestation, you do it 2 steps back. So it's like you can be profitable, or at least net positive, even if you are like half of the time offline. But there is this huge penalty for double signing. It's 1 ETH, and it's ejection from the network plus some time in the queue. So you can really feel the pain there. So
in fact, this penalty for double signing, it's not only one if, because in fact you are losing all potential income and you are losing time which you will spend in the queue trying to enter once again, for example. So it's much more than one if. And additionally, this small reward for attestation, it's only for attestation and signing attestations, but there are still probability of signing a whole block. And this income is like 2 magnitude of order higher.
Yep. But still, like, the message is pretty clear, right? You should care about not double signing, and every other thing is kind of a bit less important. Yeah. So how the network looks at the moment. We have a huge amount of active validators. Together they represent almost 25 million ETH being staking right now. Some of them, obviously, this exited amount is not a part of the active set, and only like 300 of them got slashed. So if you will like compute the fraction, it's really small. It's like 3/10 of a percentile. So it's really, really small fraction. And while we don't know the story behind each of the slashings, we know some of them, and those are basically in two categories. It's misconfiguration and it's software errors. And as far as I know, it was misconfiguration. So people were trying to fight for uptime. They basically set up few nodes, right? And after that, they've turned keys active on 2 of them, and they got slashed.
So usually human error as most of the probably worst cases in all ITSec scenarios, and the weakest point are users. So still, here misconfiguration is usually users' fault.
Yep. Yeah. So message is clear, right? So Foundation stakes 100,000 ETH. This amount actually enables us to make it properly, to stake properly without taking shortcuts or like reducing the security of the network. And on the other hand, like we can do it still like as a somewhat private business, as in we don't need to worry about the security of the Ethereum network, because this amount is like is nowhere compared to like 25 million ETH, which are currently in the active set. Yeah. So what ways we had like what were we considering when we were preparing the staking? Like those 4 methods, they are on a spectrum, right? So staking as a service, you don't run anything. You just give your ETH to some organization, or possibly you give them your validator keys, and then they run everything for you. Liquid staking as a liquidity provider, you just put your money into some contract, and then someone else will run validators for you. So it's a protocol. It's already like a bit more secure. Then there is solo staking, and there is this liquid staking as a node operator. For instance, we could be, as a foundation, could be a rocket pool operator. This would make us a bit more money, obviously. Yeah, but in general, all of those, apart from solo staking, they come with added complexity. And complexity means more potential errors. Yeah, so we went with solo staking. Low technological complexity, it's really well aligned with Ethereum design goals, because like literally people working on Ethereum designed this solo staking process. Yeah, and we had some experience in the team doing that. So this is what we went with. Yeah, so a bit more about staking as usually it goes. So you have your full node. You create validator keys, you deposit F, you wait in the queue, and your validator are active. So really simple, right? The only tricky part at the moment is this waiting in the queue, because it takes like 30 days. But still, like you need to pay attention, a lot of attention.
So what I could say about this waiting in queue is the reason why it's really hard to validate some ideas and make that quickly. Because if you would like to put some validators online, it's not that we put them online, then we are able to unstake them, quit really quickly, and then return very quickly. It's 1 month the waiting in the queue. So from the point of view of the project, it was important to start staking as fast as possible. But then it doesn't leave any time for us to verify on living organisms some ideas. So of course, we made tests on smaller amount at the beginning, but then there was this waiting time, really hot time, when we tried to prepare everything for much more validators than before to see how it will work. So because of course, some people said we have test networks and we could try on testnet, not the mainnet, but then there is a question, are we able to try on the testnet 100 tokens, 100,000 tokens from that network? That's not true. It's not possible to check the bandwidth and how it works on the testnets. So our test is made on mainnet. Of course, we made different steps of that, but this waiting time in queue was quite crucial part. Because when we already were in the queue, it means that it have to start working fine already after we'll be active. Because then any change in the whole setup, it will need exiting or maybe just waiting and missing attestations, knowing that in the final setup, it's probably more important to be protected from slashing, not from this downtime, which could, of course, at the beginning decrease your amount and give some net loss.
Yeah. So if we would go a very naive way, this is how our components would look like. So basically, you have your GEF, it's execution layer client. You have Nimbus, it's consensus layer client. They communicate through a socket. So basically, Nimbus leads GEF and tells them what's the actual head of the chain. GEF feeds back information to Nimbus, telling Nimbus about the validator set. And there is this small process which is called validator client, which is spawned by Nimbus, and it actually stores keys, your validator keys. So Nimbus already does some effort to secure validator keys by spawning a separate operating system process, which is means a separate memory stack and everything. But as you can see, if someone will break into the GEF or Nimbus, they basically overtook everything because privilege escalation in the Linux is kind of easy, and those exploits are quite cheap on the market. Yeah. So the thing is, we can actually take this thing a bit further in terms of securing the keys. Yeah, and here this cubes parts comes in.
Exactly. So I will ask the question, who out of our great auditorium knows anything about cubes? Who heard about cubes? Who maybe is a user of cubes? Okay, that's great. At least half of you. Of course, at the beginning I will tell you what is cubes, and then I will try to explain why we decided to, it means why they decided to use cubes for that, because I'm from ITL team, and we are developing cubes, and it's already our 11th anniversary that year since the first release of the cubes, so it's already quite mature project. And of course, we are usually a system for desktops or laptops, but I will try to show you how cubes in that scenario is quite useful. Not only because of security, which is built in cubes. Additionally, it's quite nice because we could use features of cubes to make the whole staking easier and more secure from the point of view of, for example, probability of slashing. Probably we need to clone the screen, and that will be fine. Yep. So I will show you at the beginning a couple of slides from our cubes presentation, and then I will show you exactly how it looks on our infrastructure right now. And on the final step of our workshop, I will try to show you our real dashboard with statistics from one of the machines, which is working right now. And I hope, as usual, live demos are not working on the conferences, but I hope that this one will work. Okay, I don't know why it's so small, but in general, QuebesOS are reasonably secure operating system. So, of course, when we are talking about cubes, we are saying about the state of the world and the threats. And to be honest, Cubes is the solution made on compartments. What does it mean? It means that we know that it's impossible to create perfect software which will protect you from all potential threats. So in fact, we know that everything could be exploited. Even small weakness in one part of the system. It could be driver in your network card, it could be some flaw in the client of Ethereum, or it could be some flaw in the parts of the operating system. For example, OpenSSH or whatever. If it's one operating system, one monolithic system, then any hole will let you in. So in fact, in the best scenario, attacker could, for example, shut down your machine. So then you are suffering from missing of attestations, from downtime. But in the worst case, attacker could steal your keys and could start double signing, so could start slashing your tokens. Of course, if you will realize that something is slashed, then those validators automatically are thrown out of the network. So but if you have, for example, 1,000 validators or 3,000 validators, then it means that you could lose, because of slashing, for example, 1,000 ETH. It will be quite pity to lose so much. So of course, what is the idea? This is the single system. In the cubes, we are doing that, of course, humans. We are doing that in the idea of compartmentalization. It means that we are trying to divide the system in the separate parts. We are putting in one part network, internet controller, NIC, and drivers to that. In different part, we put, for example, different clients. And I will show you exactly what is the scheme for our stacking right now. And Cubes is based on virtualization. So it means that we have hypervisor, which is working below as the barebone of this system. And on top of hypervisor, we create services, and we made all of this bunch of VMs working together usable as a single operating system. So right now, for basis for the cubes is Zen hypervisor. It could be something else, but since this 10 years we are using Zen, and we made a lot of services which are communicating inside with a very defined, very small communication layer. It means that there are so simple protocols for communicating them that it's really easy to audit them. And of course, users of our solution, there are different companies. I will show you some logos and some projects that were audited. And for those solutions, we know that, okay, this layer of communication is really fine audited, and we could trust that. And of course, we decided to change this typical system to the QuebesOS way, where we could create not only small compartments, which, when they are exploited, are not so easy to affect the whole system, but additionally, we are able to create policies, allowing communication or not allowing, or changing the way how we could communicate, how we could monitor and verify what's happening. So in fact, we are everything dividing, but why it's unique, it's because we are able to configure everything, we have explicit policies, and then we are able to separate configuration from the data and how it works. And of course, origin of cubes are the systems where we are sitting in front of the computer. It means that laptop, workstation, or desktop. But we are able to use the same scenario on servers. So of course, it's still possible. And why we decided to use cubes of that? Because at first, there is this security of operating system. That's obvious. But additionally, what are the advantages of using cubes-like solution for staking? Is that if you are going to try with the high availability scenarios, you have additional features for protecting of double signing. Because, of course, at one of the level, when you have a lot of validators, and that's the case which we have right now, you start to ask, what is the cost of 1 hour of downtime, or 1 day of downtime, or 1 minute? And then you are able to realize that this cost is, in fact, counted in thousands of euro. So these thousands of euro could be used in Octant project for fueling development of the society, world society. So it will be waste of resources to not gaining that profit. So of course we started asking, okay, what we could do to make the better availability and higher uptime. Then we should find the ways how to, for example, be sure that when we are moving keys from one machine to a different one, that for sure on the other one, there won't be any copy of those. And for example, with Qubes, we are able to not only turn off part of the system, because in fact it's everything enclosed in one VM. We are able to remove Ethernet controller out of that. We are able to destroy the virtual machine. So in such a way, we are sure that there is no more copy of keys and no more this part of the system which was responsible for signing parts. If you have monolithic system where you have the whole node working at once, it's not so easy to destroy those. In our case, we are able to just remove Ethernet, we are able to remove the whole part, or we are able to restore the new signing component because we have special templates, and we could just copy template, of course, empty template, and then put inside keys and start signing, for example, different validators or restore those. So thanks to Qubes, we have these additional features for example, updating parts of the system thanks to templates. Additionally, we are able to create secure scenario for copying keys between VMs and in fact different machines with the idea of the QuebesOS protocol. And finally, of course, we are able to be sure that the validating client is not working anymore when we don't want to. In general, Qubes is quite simple for management. It's because we base on policies. User interface is not visible when we are working on servers, but still, if you like, you are able to log in to those. And now I will show you how looks our setup with this exact scenario, but who is using Qubes? So if you are not familiar with Qubes, maybe some quotes. For example, Edward Snowden. He is one of the users of Qubes, regardless if he is Russian spy or not. I don't know if you believe that theory, but in general, he said that he gives him power. And that's true. When I started using Qubes, right now I feel strange when I need to do something which is quite related with privacy on a computer which is not working Qubes. For example, right now I'm not able to log into any secure service like banking or something else on a different computer. It means that I feel like in a car without safety belts. You feel somehow naked. And it's the same feeling which I have right now when I'm not using Qubes. So of course, sometimes I am not able to log in somewhere because I don't have my Qubes. And you see different quotes. Maybe what is quite important there is to mention one person from the community, ETH community, who said something about Qubes. There are different companies and foundations which supported Qubes, which are using Qubes, and fueling with donations, of course, Qubes. So let me show you right now. Okay, some quotes. Okay, so maybe this one. I don't know, Vitalik Buterin, this guy said once, trying out QuebesOS, and that is a distro designed around increased security and surprisingly good user friendliness. It's something what we got as sometimes comments that Qubes is really hard and how should I use Qubes. So in fact, he said that it's fun enough. And for server operators, of course, it's really easy. But that's true, that Qubes recently is used mostly by expert users, maybe not expert users, more power users, let's call them. It means that users who are not afraid of Linux. So in general, when we are thinking about servers, it doesn't matter because your sysadmins probably still are good enough to operate with that. You are not afraid of command line interface because Geth, Nimbus, never mind, whatever, usually you just spawn them with the command line. And additionally, there was one other quote from the same person. He said that if someone has 1 gig euro or dollars, they could pour that into Qubes-style secure operating system, and it will be something like Manhattan Project for cybersecurity. So it will be a nice future. I believe that there will be someone who will pour money into the project. But let's go back and see how we're doing this solo staking right now. OK, so here we have two general pictures of cubes. In general, this is one example of architecture of cubes. It means how we divide different parts of the system based on the level of trust. So we have level of trust which is safe and ultimately trusted. It means that we don't like that level. In the best scenario, there won't be any part which we need to trust. But of course, there is a hardware, there is user and operator. And of course, there are parts which are unsafe and untrusted. So in general, as you see, we need to somehow trust into our hardware. And that's true right now. We have our server room. And we need to trust operator of that server room and the hardware which we bought for that. And of course, there's different ways how to make sure that your hardware is secure, that you are not buying them directly as a foundation, advertising that we are going to stake on that hardware something. But of course, it's the first step with this hardware-related paranoia that you just taking a look how you obtain the hardware. This plot is in fact on our website, QuebesOS.org. And then there is this additional layer. Of course, here is this hence hypervisor. We have administration VM. And one level deeper, we have different parts. And for example, as you see here, we have network VM. And what is important? In our scenario, hardware like network interface, it's not directly connected to the application VM. Here, this application VM, here, of course, you can see some clients' applications. But in fact, in our scenario right now, here we have GEF as an additional VM. It could be Nimbus, it could be validator. So, of course, we don't trust our hardware, our Ethernet connection and Ethernet card. So Ethernet card is connected to the sysnet VM. And it's our first step of security and our first step of defense. It's this sysnet. So we have physical hardware and driver moved from the DOM 0, so it means this hardware layer, directly to the separate entity. And then, if someone will be able to penetrate sysnet, then there is the second level of protection. And then we have sysfirewall. It's a separate entity, separate virtual machine. So in fact, here you have hardware. Hardware is connected to the sysnet. Here is the Ethernet connection initiated. Then there is the firewall as a separate virtual machine. And then firewall is the place where all of the applications VM are connecting. So for the very simple scenario, where everything will be working in just one virtual machine, like here, we need at least 3 virtual machines for that. So network stack, firewall rules, and finally, applications. But of course, we are going a little bit further. And what's important when you are thinking about cubes, and probably part which is the trickiest for users, is that you have to configure this part when you put your own services. So of course, when you install cubes, by default, you get something like that. So it means we have this setup set as a default. If you are not pro expert and if you are not checking the mark, I'm expert, please do not configure default VMs for me, you will receive something like that. And additionalities which are quite characteristic to cubes are disposable VMs. It means that if there are things which we would like to try, we are able to just boot up one virtual machine to make some operation and then destroy this virtual machine. And of course, for easiness of managing, there are templates. So those templates are prepared, pre-configured, pre-installed with some software virtual machines, which then are started in these app VMs. The greatest pain for users sometimes are, OK, how I am able to divide my scenario of usage into different VMs. So of course, when we are thinking about the user in front of computer, we could divide it into the work with different areas related to work. Then we could divide it to, for example, personal stuff or some red browsing of websites with funny pictures. Everything could be divided. In terms of solo staking, it was much easier because, in fact, we have just one meta service, staking, but it's divided into 3 parts. So let's take a look what are those parts. And here is our, I hope it's visible. OK, so in fact, it's our scheme for solo staking on cubes. What it means? It means that here is our machine. This blue square is the concept of our hardware. And then inside hardware, of course, we have sysnet. And here we skip this firewall part, but in fact, of course, there is this firewall somewhere. So there's the sysnet and firewall net. And here's the part related with staking. And here we have 3 separate virtual machines. Of course, one virtual machine is execution client. And here right now it's Geth. But of course, it could be something else. With Qubes, we are able to create template and next virtual machine with, for example, Nevermind, and put it as a separate entity there. So, for example, switching to the different client will be quite easy. Then, as a separate one, of course, there is consensus layer, and right now it's Nimbus. And part of the Nimbus, it means that separate Nimbus validator client with keys is in a different VM2. And what's important? Of course, consensus layer and execution layer, those two need to be connected to the internet. So if there is internet, then there is connection to the sysnet. So of course, as you see, there are already arrows connecting Geth and Nimbus with internet. And there, of course, we have some bandwidth. For one machine, it's something like 60 megabits per second. So to be able to have more machines, and I will tell you something about the numbers in a couple of minutes. It means that this connection needs to be stable, and you need quite high bandwidth there. But in terms of validator, is the hottest point from the perspective of security. They are the keys, private keys for signing. So it's the part which you would like to protect. And in our scenario, this part is not connected to the internet at all, not to the network. It means that, as you see, there is no connection between sysnet and ETH valid, because we are using our internal mechanism for communicating between validator client and consensus client. We use QRexec. QRexec is internal way of communicating between machines in Qubes, and we are able to put into QRexec TCP connections. So in fact, there is a special layer of communication on Qubes, which we use for that. And of course, we are able to define policies on that, and even we are able, for example, to create our own wrapper for those connections, and we are able, for example, to check what is put through that pipes. So for example, if there will be need for that, we are able to create our small proxy, which will be reading that traffic between signing validation client and consensus client, and check if there won't be any requests for the same, for example, epoch slot to be signed twice. We are able, but right now we decided that there is no need for that, because in Nimbus there are already some features which prevents that solution. But what gives us Qubes? Qubes gives us the possibility to connect those two boxes through our internal mechanism, which means that we don't have to use the network stack of the operating system, which is the main operating system of the machine. So, for example, in the scenario of high availability, we lose connection to the internet from this machine. And this machine is looking that, okay, I don't have access to the internet for longer than some thresholds, like 10 minutes, 1 hour, or 5 hours. And in such case, if this threshold will be reached, then the machine could, for example, delete the whole VM. Delete or turn it off. There are different scenarios for that. If you would like to be really, really serious about security, and we need to be sure for 101%, then we could delete that machine. If we believe that nothing will turn on that machine, we could just turn it off. But when the machine is deleted or turned off, it means that we could boot up or already put those keys into a different machine, in different ETH node, which was working already somewhere in the network, waiting for this disastrous scenario when one of the nodes was lost on our side. And what is good about this scenario? There are still working two clients. So it means that, for example, if it was only problem with some tractor destroying fiber optics somewhere in the ground, and then the internet connection will be restored, we have already everything almost configured there. It means that there is already 1 terabyte of data with Geth. There's already a couple, maybe 100 of gigabytes of consensus client data. So we don't need to synchronize once again since the beginning this machine is already almost ready for operation. So then we are able to, for example, put here different amount of validator clients, and we are already working. It means that thanks to this mechanism, which is in fact thanks to the cubes, we are able to quite easily create high availability scenario, which will be still on one level more protected from slashing than the normal setups, where everything is in one machine. And of course, we need something for monitoring that stuff, because it's not really easy to put everything in the computer, turn it on, and believe that everything is working. At the beginning, 3 months ago, we thought that it will be so easy. But unfortunately, all of these clients, they are not so well tested, especially not well tested with so many validators, because in our case, we are talking about over 3,000 validators. So some of the scenarios, or maybe amounts of the RAM memory consumed by the processes, were unknown to us, especially because testnet was not able to provide us any real-life scenario. It means that number of peers in the testnet and volumes of traffic, they are completely non-comparable with the amount of traffic which you have when you are staking 1,000, 100,000 of ETH. So for monitoring that, we created a separate sysnet management part. And this part is connected not only to the P2P network, but is connected to the VPN network. Because this part, this sysnet, is able to connect with the world, with the public IP address, but here we are going and we are allowing only P2P traffic from Ethernet network. So we are able to verify what is the traffic and allow only that traffic. But if you would like to SSH in the computer to make any management, if you would like to see what's happening inside, we have some monitoring. So we created additional monitoring VM. Here is our Grafana working with plots and graphs. And of course, to access that, we have VPN network. So behind the VPN, we are able to SSH into the management VM, into the whole cubes and operate it. And of course, we are able to see how it's working. And on the next step, we are going to create one master dashboard for all of the machines, because of course, we decided that it's not the best to solo stake on only one machine. We decided to use dozens of those. So of course, right now, this is setup of only one machine. So right now, if there will be, for example, 10 nodes and 10 machines, then there will be 10 monitoring VMs and 10 dashboards. So of course, if you have a large enough display or a couple of displays, then it's possible to have 10 plots. But of course, it's better when you are able to merge the most important metrics in just one. So it's our next step, which we are going to develop for that reason. But in general, what were the main problems which we faced when we were preparing everything? When you are dividing hardware into different VMs, you need to think about physical stuff below. This physical stuff below is something like storage. What should be the amount of storage which we assign to the GEF, to Nimbus, and to the other part of the systems? Because we need to take care of that, because of course the blockchain is growing, the amount of data which you need to store is growing. With cubes, we are able to quite easily divide those parts, but at the beginning, we need to prepare that. Additionally, there are of course cores, CPU core for signing and for calculating cryptograms, and there is RAM, so random access memory. And for example, GEF is a beast which is able to consume all of the RAM you have on your system. And additionally, it's able to consume all of the swap which you have on your system. But what is really surprising, when we had set up with 128 gigabytes of memory dedicated to GEF and 1 gigabyte of swap, we found that GEF consumed all of the RAM and consumed all of the swap and then stopped working. So we increased amount of swap to 10 gigabytes and we restarted everything. And suddenly, GEF consumed 128 gigabytes of RAM, and then nothing out of swap. And we made this experiment a couple of times, and always when swap was really small, GEF was able to consume everything. So finally, we found that it's enough to start GEF with only 32 gigabytes, and it's working. It means that most of the RAM is consumed by cache, and we don't know why when we have our SSD drives, which are so fast that they're almost the same speeds like RAM. When we made synthetic tests on RAM disk, and SSDs, there are something like only 10% or 15% of difference. So when you have SSD drives which are able of writing 7 gigabytes per second, it's really a lot. So probably, of course, network is not giving you more data than that. Additionally, with Geth, there is this small problem that we don't know exactly when Geth is making snapshot of the files on the hard drive. So sometimes when we were killing Geth to check what will happen if there will be loss of power supply, Geth, after reboot, needed only 15 minutes or half an hour to synchronize with the network. But sometimes we got message that there is corruption of data for last 3 days. And we had to wait a couple of hours to restore that. So, of course, it's great to have multiple of machines to be able to move validators in such situation when we are restoring them. And in terms of, for example, Nimbus, and what here could be a tricky part. When we are connecting with validator, we use sockets from this QRexec. And sometimes Nimbus is spawning so many sockets that kernel is not able to properly close them and is closing them in the smaller tempo than opening the new one. So you are able to consume all of the RAM, or you are able to find the soft lock on the kernel and then just lose VM with consensus client. But luckily, our team was able to find how to patch Zen and how to patch kernel, and we did it, and it looks that it's working fine right now. So our first test, what will happen if we will spin up 400 validators on one machine, and it was able to work for 4 hours. After 4 hours, we consumed all of the slots and kernel stopped working. So that was fine. That was planned that it will stop working somehow. It was after 4 hours. Then we put our patched kernel, and right now it's working already for 1.5 days, because in fact, it's everything really hot and new. Today, during the night, probably 1,000 validators more will be online. And of course, there will be more interesting to us. It means that on more Graphanas, there will be something interesting to watch. And this is probably the moment when I will show you how looks our Grafana, because there's already 30 automatic suspend. Yes, thank you. And then there will be time for you to ask questions. So right now, this will be this tricky part when I will try to take my laptop, connect to our secure VPN, and then give you an idea how it will look like. And what is the final message? That the whole work which we did and which we are still doing, we plan to create a white book about it. We plan to create some how-tos, tutorials, manuals for the community, how you are able to use cubes for solo staking. And what we've learned from all this great journey of solo staking, it means that we are able to tell you what could go wrong, or we are able to tell you what could happen with different drivers of different network controllers, or for example, how to maintain sync of clocks inside the VMs, because as you see, in this validator VM, we don't have network. So it means that we are not able to use network time protocol inside it. But luckily, there is Qubes. And in Qubes, we have Qubes sync service, which is synchronizing clocks of the VMs in the real time. So we are able, of course, to maintain the synchronization. I need to connect somewhere. If you could help me, it will be great. And of course, we tried what will happen if there will be no Qubes sync time sync service. We found that quite fast VM is starting to have synchronization worse than 800 milliseconds or worse than 1 second. And of course, it's the moment when consensus client is starting to shouting that, oh no, your clock is destroyed, I'm completely out of sync. So then it was for us obvious, okay, so we need to start synchronizing the clock, and it started working once again. Okay, so now I will connect to our secure VPN, and I will try to show you how it's looking. Okay, I'm connected, And I'm refreshing. Perfect. It looks that it's working. So right now, let's believe that my Qubes-based laptop is able to show anything on HDMI output. Okay. Something happening. Perfect. It's Qubes. It's working. Okay. As you see, it's a dashboard from Grafana. Nothing fancy. But what we are able to see here. For example, we are able to see this part of the test related of the old kernel on Nimbus. Here, as you see, is network transmission rates. So we are consuming something around, let's say, below 100 megabits per second per every node. So it's the moment when we finished waiting in our queue for over 1 month. So it's the moment when finally our validators started validating. And then you see that, of course, the network rate started to increase quite quickly. So we reached this plateau of consumption, which here is around, let's say, 70 megabits per second. And of course, Nimbus started to create a lot of sockets. And after a couple of hours, everything crashed. It means only one machine crashed. And it's thanks to Qubes that our GEF was still working there. So we are able not to lose the sync of the GEF. But of course, we lose Nimbus for a while. Then we changed the kernel. We started once again the machine. And then we had to wait for sync of the Nimbus. So of course, we decided to wait this time to check how long it will be. Although we rebooted the machine in something like 5 minutes. It means that we were aware that probably something will be wrong. So we were waiting. We saw, OK, it's soft lock. Then we killed the machine, rebooted with the new kernel, and then started waiting for resynchronization. It went really fine. After a couple of hours, like 2 hours later, we started working once again. And here you see attestation rate. It means that is attestation rate of the node, which is operating here. So we are somewhere below 4,000 attestations per hour. So it means that, in fact, we are attestating here with 400 validators. Is it large amount or not? We could take a look on the consumption on our machines. And here are 3 VMs. Of course, execution client, consensus client, and validation client. So as you could see, in terms of CPU consumption, we have here, for example, 16 cores dedicated to that. And there is a lot of space left. So probably we are able to validate not only 400, but maybe 1,000. Maybe we'll check that on some time. But right now, in terms of CPU, it's fine. This machine here, it's 24 cores, 48 threads. But from the security point of view, we are using only cores, physical cores. We are not using threads. Then memory usage. As you could see, this one is our GEF. So 32 gigabytes, and of course, most of that is cache. And sometimes it's growing. For example, app is already something like 14 gigabytes. So it's growing too. But then there is a swap usage. And right now, everything is free. That's fine. When there is some problem, or maybe when there's a high peak of data, you see that I/O weight is higher on CPU. It means that we are waiting for I/O on our drives. So these peaks are related with the events like resynchronization, or like here, you see, it was this downtime on Nimbus, so afterwards there's high peak because Nimbus started to put data to our execution client. And when we see consumption of memory on other machines, of course, we see that it's really manageable. In terms of our validation client, it's almost nothing. In terms of consensus client, here we put 16 gigabytes, but still at the moment, app is using something like 5-6 gigabytes. And when you see that there are some drops of RAM memory in the machine, it's because in Qubes we have this dynamic RAM assignment possibility. So we are able to change the pool dynamically between the machines. Of course, we could switch it off. For example, for GEF, it's stable because GEF is able to consume everything. But for Nimbus and Nimbus validation client, we have this active. And here, it's network transmission. So we see that for GEF, it's something like single megabytes per second, but for Nimbus, it's 60, 70 megabytes per second. And of course, we don't have network controller in our validation client, so here is no data. So we don't have it. And of course, we are monitoring different parts like storage, because of course, storage is quite important when you have this whole block. So as you see right now, we are able to manage that. And thanks to Qubes, it's quite easy to change the pools in different VMs. So right now, every machine has its own dashboard. And our next step will be to create a single dashboard for all of those. And our next step is the idea how we are able to validate and check what is the real performance of every single validator. What is the tricky part right now? Because when you look on the external services designed to monitor your validators, you see that for the basic free version, you are able to monitor, for example, 100 of validators. But there is a special tier for whales. And with whale tier, you are able to monitor 180 validators. So in our case, we need to monitor 3,200 validators. And of course, there is no tier for us. And buying whale tier times 10 times, it doesn't have sense. Because in fact, it still means that we have to look on 10 dashboards. So probably, we'll need to design our own solution with, for example, Nimbus node dedicated to the monitoring of the performance of the validators, not only rough estimation that what are the number of attestations per hour, but for example, how many blocks were caught, or for example, what is the real income, because then of course it will be used by Octant project at the end. So we started, first 400 validators is already working, as you see. It's working in the real time offset between VMs 63 milliseconds, so that's fine. And during that night, 1,000 more validators will be online, so additional dashboards will be more interesting too. And of course, the whole project is going.
Should we have some questions? Because we have like 10 minutes more. Sure. Let's use the mic because we are being recorded and this is the only source of the sound.
So from what I understood, if you go to back to the dashboard, so all of those VMs, they are running on the single machine.
Yes, that's true.
So the memory consumption and also like CPU, it's so low for the consensus layer that you are able to spawn so many VMs?
Yes.
All right,
it means that right now, I will return to this first dashboard because I tried to open for you the dashboard from the previous machine, because right now we have two machines which are already working with the clients which already went into the online state. On first one, we have 62 validators. So it's the one which we tested everything. We started with 32 validators. It means 64, then we divided into two machines, we tested different scenarios, and then we started with this 400. And of course, during that test, we decided which will be the best hardware. So when I tried on the internet to ask, hey guys, what hardware do you need to put 3,000 validators? People were, what, 3,000? We don't know. And so we made some tests, synthetic tests, based on the information which we found and on those what we tried to benchmark there. And we realized that probably 64 gigabytes of RAM will be enough, and 24 cores will be enough. And that's true. This machine with 400 validators, it's working with 24 cores which are on, and 64 RAM. But of course, it's server machine. So we are able to put 24 additional cores, just populate the second CPU slot, and we are able to put 1 terabyte of RAM if there will be need. But 64 is enough for up to 500 validators. We checked that, and it's working. Maybe in a month or two, we'll be able to tell you if it's enough for 1,000. Maybe it's true too.
Nice, nice. That's surprisingly low. So another question. In your opinion, what are the pros and cons of this approach compared to something like deploying each validator node separately, for example, in a cloud, in like a Docker containers or something like that? Because that seems like, I think, more common approach, I guess.
I think that it's the main question, meta question related, are we going to trust to someone else and give them our keys or not? So I believe that Foundation here decided that it will be probably the best to have our own keys with us together and to be responsible for what's happening there. Because when you have cloud solutions, it's possible that when you are working on cloud, in fact, there will be 2 copies of your machine because you don't know what's happening below the hood, behind the hood of the, for example, Google Cloud. It means that you see in your dashboard there's only 1 machine, but what will happen below, you don't know exactly what will happen. Of course, one way is that there could be some malicious operator who could, by intention, destroy something, or sometimes the backup mechanism could make the situation when there will be the ghost machine of yours, which could try to connect to the internet. And I know, of course, not the staking scenario, but the scenario of scientific data collecting service, when one of the machines had 2 copies working at the same time because it was copied to the second data center, and those mechanics made that the first data center not switched off the machine. So, of course, in this scenario with the clients, probably the second client with the configuration with the same IP address will have the problems with getting enough P2P nodes to start propagating. But we check that even behind the NAT, when we put one of our nodes behind the NAT, number of peers were enough to sign attestations. So it means that even if we'll change IP address, public IP address, so this cloud scenario, this machine was still able to attestate. So double signing scenario is possible there.
Thanks. That makes total sense. So what are your plans if you eventually run out of some resources and you need to spin up another machine? How would you approach it in such case?
In general, our idea is quite simple. For example, right now, we have X of the machines plus additional couple of machines which are our spare machines. And we use them for tests. Like I said, the Nevermind test will be probably one of the next steps which we'll try. And of course, when we'll see that we are going out of resources, our next step is to power on next machines. And additional, thanks to our spare machines, we are able to just increase number of hardware. It means that, okay, there's spare machine. We see that 64 gigs is not enough. So we are putting into the spare 256 gigabytes. We put additional CPU, or we put fiber optic Ethernet controller there to have 10 gigabits per second. We put that inside, and we are able to move validators. Right now, we built into the cubes a mechanism for moving keys between machines, because it's quite tricky too, because right now, when we are creating keys for the validators, those are created on the offline machine, like on the secure terminal. So it's a cubes machine which is unconnected from everything. And then, inside the validator client VM, we create GPG pair of keys, which is our transit keys. So then we send this public key with Cube's internal mechanism, which is unrelated to the network. Then we pass this public key to our secure terminal. We sign this transport package with the validator keys. We put them in the validation machine. And of course, for the high availability, we need to make scenarios when one set of validators is signed by 2 or at least 3 keys, because we have spare machines. Because it's simple to say that when one of the machine goes down, you need to restore validator keys for that. If the machine is still working, but you lose, for example, Geth or Nimbus, you are able to copy directly with this encryption mechanism. If not, because the machine is doomed and exploded, then you need to restore those auto-encrypted copy. So right now, we have at least 1 spare for every key, validator key. So it means that when we lost, for example, machine A1, then B1 or C1 from different sites will take care of that. And of course, the whole setup is made in many sites. So right now, we have a couple of servers in site A, a couple of servers in site B, a couple of servers in site C. And we are able to, and in our future idea is that we'll be able to manage the load, for example, and the backup between all of these sites. And of course, we could put different sites under different jurisdiction in different countries to be able to maintain the operation of the nodes regardless of what happens around.
What about Nethermind? Are we going to use it in the near future? Answer is yes, we will. Just for the guys.
Yes, it means that at the beginning there was someone told us, it was the guy named Pepesza, he said, On my setup at home, I use Gef, so let's try with that. And we started with Gef, but then a guy named Pepesza said, what about Nevermind? Maybe you should try with Nevermind. But then there was a really serious guy called Julian. He said, okay, but there's no time for that. Let's try with Gef because it's working. So we started with Gef, and of course then the guy called Pepesza jumped in and said, maybe let's try once again with Nevermind. So of course, with spare machines, we'll be able to try that, and of course we'll be able to make side-by-side tests, and for example, to prove that what is the amount of RAM consumed by different clients, and we will be able to ask you how to make the Nevermind better solution for that. And of course, it's possible to switch between different clients, because in Qubes it's really easy to create a second template with different client. Of course, at the end there will be question if there is enough of memory there to be able to store on one machine different copies of chain, but of course we are able to put additional hard drives there, and of course then it will be doable. So with Qubes we are able to quite easily test different scenarios. I'm still trying to connect to the old Grafana, but I need to take a look for the very secure password to open that, and I will show you a couple of days of Grafana logs. Okay. What's funny that it's really interesting for our team too. So it means that even Marek, who is the lead developer of Qubes, is really happy or maybe motivated to work on that. And he was working together with this team responsible for deploying that very closely. And thanks to him, we will be able to, for example, deploy quite easily patches for the kernel. So it was adventure for the whole team. Okay, so I think that it will be here. Yes, I did it great. So here we are deploying this our older Grafana dashboard. It means that we are improving even how looks our dashboard between Grafanas. Oh no, it's already updated. Great, so team is still working. So here you see it's the different client. It's our first client, and this one is working with only 64 validators right now. But the consumption of resources is quite similar. Of course, this memory is a little bit tricky here because it counts cache as consumed memory. So in fact, it's not always true. Here you don't see any hole because this one was not affected. For example, we still try to understand what happens with our attestation accuracy, which is usually related not exactly with our performance, but the performance of the Ethernet network. If network, and for example here, attestation rate, you see those peaks and maxima and minimas are not related with the bad performance, but here the fluctuation is really small. Attestation rate per hour is almost constant, around 578 attestations per hour, because here we have 62 validators. I will try to show you how it looks like one week. I hope that my browser won't explode at that moment, because I don't have a lot of RAM in my laptop. But for example, here you see the moment when we changed amount of validators on that particular machine. Here, as you see, there were 32 validators, and then we moved additional 30 validators to the machine. So of course, we see quite a large increase of network transmission there. And on all of the interfaces, of course, number of peers were stable there, but when we take a look on the resources, for example here, okay, here's huge peak in CPU consumption. But what's surprising, when we put 400 validators, there was almost no increase in CPU consumption in the comparison to the 62 validators. 62 because, in fact, we started with 64, then we made controlled exit of 2 of those to verify that we are able to exit, and then we returned. And even you see how stable is the consumption of RAM for the 1 week, for Nimbus, for Gef, and for validation client. So everything looks fine. And of course, this increase of network traffic because of validators which moved to that machine.
Any more questions?
Thank you very much.
Thank you, guys.
That's true.
How to set up this thing? I'm thinking about a staker who is not so technical as, for instance, Vitalik. It was easy for Vitalik, but for some stakers.
To be honest, as I said, it's probably it will be our plan. It means that for me as a part of the Qubes team, it's something quite obvious that we should create a white paper about it or the white book, which will exactly explain which parts or even the salt formulas for that. Because everything was built in salt, so you are able to quite easily copy that. And I think that's work which should be there.
You are away from one install software.
To be honest, if you're able to deploy cubes, it means just install plain cubes on your computer, we are almost there. It means right now there is software which is putting comments inside your command line and doing everything in one click. So right now when I will call Marek, I need one more machine, and here is entrance to the management interface of that machine, and here is the public IP. Just power it on. So for him, it will be just putting the first command, pressing enter, and waiting, and that's all. And this machine will download everything what is needed. Then the machine will start synchronizing, and finally, it will start validating. So we are really close. Maybe there are some tricks which are important to remember. For example, hardware compatibility. There could be possibility that, for example, your network card, if it will be quite strange card, won't be supported by Zen. But in case of servers, most of the cards are supported. But for example, if it will be Intel card, I think that all of those works. We had some problems with some Broadcom chips, but it was one of the potential problems. But in general, yes, just hardware problems. But in general, installation of everything after the whole route which we go through, it means that putting all of these formulas together, there are, of course, parts which you need to configure, like putting these secret calls inside or generation of the key. But if you are aware how the clients are working and what you need to define, which variables you need to fill, then the setup of cubes shouldn't be quite hard. We are doing that in the one click and just wait for the installation. And I believe that finally there will be some Octant-related documentation for that. We just need for the support for someone who would like to pay for the food for developers to write that. But in general, I think that we are not far away from that. Maybe not KubesCoin. I think that some fiat will be better because we are paying for food with fiat.
Cold, hard cash.
But in general, it means that as a Qubes, for many, many years, we are not really happy with crypto world, with proof of work scenario. And we would like to be really fair against the world. So I think that staking idea, it's idea which is much more aligned with our principles in ITL and QuebesOS. So we would like to be part of that change if it's staking. And of course, if there will be people willing to give us tokens, which we could then switch to the money, which will give our developers possibility of living, then that's fine too. So maybe we will be on Octant too, if they will invite us there.
Have you got any money from the government recently?
From government?
Yeah.
Not.
You're green.
It means that not Qubes directly, not. We have some EU-funded grant for something, but it's not from government directly.
Anything else? Any more questions?
And it's still working there.
Yeah. If not, we can wrap up. Oh, yeah, sure.
Could you repeat that about EL memory? Did you have problems with GEF memory usage?
Yes, it means that GEF was consuming a lot of memory, and in fact, what was the most tricky part of Geth? I'm not, maybe I couldn't find that. How to force Geth to make snapshot of the database state. Because sometimes Geth, after closing it in the unclean way, needs only a couple of minutes to synchronize, but sometimes Geth is telling that 1 or 2 days or 3 days of data was lost.
Do you mean synchronize after restart? Or?
Yes, synchronize after forced restart. Not the clean shutdown, but after the forced restart. And sometimes I see counter in the logs from the Geth, like creating snapshot. And I believe that this snapshot is the way of writing down to the files the state of the chain. But we don't know how to force it, to make it, for example, once every 8 hours or every day. Because when we tried, sometimes this unclean shutdown was because of some problems with software or with the kernel or with the power supply. But sometimes it was just we decided to put system shutdown, service shutdown in Linux. And systemd looked, OK, I'm waiting already 2 minutes. It means that I need to make forced shutdown. So the systemd killed the process. And then a couple of minutes later, we just make start, and the Geth told us, OK, I need 3 days to synchronize. And we were waiting 8 hours.
In systemd, there is some, I don't remember exactly what is the flag, but there is some flag configuration for gracefully closing. And it's the key for Geth to add around 30 seconds to give that time to close the whole Geth gracefully.
Mm-hmm. In our case, we give it 30 minutes. It means that to be sure. So even 30 minutes, we put for the graceful shutdown. Yes. It means that once we waited really long, and finally after something like 12 minutes, it was able to close gracefully. So it means that right now when we are doing our administration tasks which are planned, we decided, OK, it could be something like half an hour. We could wait even half an hour, because when we scheduled our maintenance for like 24 UTC, then we could just start switching off 1 hour before or half an hour, just to be sure not to lose the sync so much. I don't think if there's need for Windows version. It means that I don't know anybody who is taking stuff on Windows Server. That means that is pointless. You are able to start.
Have you guys heard about such cases? A few, okay. I mean, brave souls, aren't they? Brave souls, yeah.
It means I don't see future for the Windows. It's yes, in general, it means that in the modern world, I think that there are probably no advantages of using Windows incomparable with Unix-based systems, and especially on servers. Even if you will compare what are the prices on cloud solutions between the Linux systems and the Windows-based systems, is completely without any sense to try with Windows. But if you are willing to open your Microsoft Office on Linux, then it's possible. And even recently, I found that Microsoft web browser called Edge has official Microsoft packages for Linux.
It works great. You can use this GPT something.
Bing AI.
Yeah, Bing AI, yeah.
Yes, because Bing AI works only in Edge, and Microsoft created Linux-based Edge. So probably Microsoft is going to the direction of Linux. So they already made VLS, so it means that maybe Windows will be just on some playing stations for gamers. Even whole GPU-intensive task right now, like AI training, is built on Linux. It means that I don't know anybody who is training virtual AI networks on Windows. There are people who try, of course, but most of those are people who are just gamers, and they have fancy GPU, and that's the reason why they try it. It's not that they're building a GPU workstation, and this station is built on Windows.
Thanks.
Thank you very much.
It was really nice giving this talk.